Okay, welcome back, and we're going to start talking about the characteristics of an exponential function. So, what are some things to keep in mind? So here's an example of an exponential function. So this is an exponential growth function. Okay, so here are the characteristics. So first, the general form is f of x equals a, where a is called the initial amount, okay, times b, or we can also call this the coefficient, but a is some positive value called the initial amount, or initial value, okay? In fact, let me put that here. So the initial value. And then we have the base, which is b, raised to the x power. So this is the general form of a function, an exponential function. Now, a can be obviously anything except 0, because for obvious reasons it won't be an exponential function anymore. Now, b can't be 0 either, because again, for the simple fact we won't have an exponential function anymore. But b can be positive, bigger than 1, or positive between 1 and 0. So it's always a non-negative number not equal to 1. Okay? Did I say not equal to 0? I misspoke if I said not equal to 0. But b can't be 0 either, but b can't be 1 either. b can't be equal to 1. For the same reason, we won't have an exponential function. So b can't be 1 or 0. Now, but it's non-negative as well. Non-negative or non-zero, yeah, non-negative. How would you say that? A positive real number, so I'll say a positive real number not equal to 1. That's good. So b can be a positive real number not equal to 1. If it's greater than 1, exponential growth. If it's between 1 and 0, exponential decay. Okay, just like we saw in the previous video. Now, the domain of an exponential function is all real numbers. It's always going to be all real numbers. Okay? The range, on the other hand, depends on a. If a is positive, then it's going to be all positive real numbers, like in this case. If a is negative, then it's going to be all negative real numbers, because what happens is when a is negative, it's a reflection across the x-axis. So it becomes, all of the positive values become negative. Now, notice that the y-intercept always goes through 0a, right? Because if x is 0, this becomes 1 and you just get a. So the y-intercept always goes through the point 0a. Now, and there's also a horizontal asymptote through y equals 0. So the x-axis is a horizontal asymptote. Now, most cases, if we want the simplest form, we would just say a is equal to 1. Okay, now if a is equal to 1, what happens is, and I'm going to use my graph here as an example, if a is 1, there's another characteristic of exponential functions, and they always go through these 3 points. So in this case, I'm taking the more simpler form, which is just f of x equals b to the x. Okay? Now, in this case, a is 1. Okay? Now, that means that this function will go through 0, 1. Okay? It'll go through the points, these 3 points. 0, 1, 1 comma b, -1 comma 1 over b. So in this form, we know that the exponential function will always go through those 3 points. Now, what if we add the general case b, a there? Well, that means what will happen is those points will change slightly. So this general form, now again, once you know these, then you can easily just apply it to this, except you're just going to multiply by a. So the 3 points would then become 0, comma a, which is the intercept, right? And then it would be the y-intercept. And then 1 would be 1, comma ab, right? And then the other one would be negative 1, comma 1 over a, no, I'm sorry. It's going to be a over b. Okay? So that's another thing that you can always write. So the general form, f of x equals a b to the x, a times the quantity b to the x, will always go through these 3 points. And if you want help remembering it, if you just remember this simple form, then you could just multiply this by a and you'll get them. And that's it. So now we're going to do some examples in the next video and we'll go from there. Have a great day.